Okay, so I'm going to start. All good with the sound? You have a volume here if it's too loud or too weak, if you want to change. It's all good? Again, it's a bit of a strange thing not to have any feedback from speakers, while you talk. But anyway, so my name is François Deffarges. I am Engineering Support Director of NEXO. Our mission at NEXO of Engineering Support is really to help our customers, whoever is dealing with our solutions, help them, assisting them on all the technical aspects and all the engineering aspects. So inside that mission at Engineering Support, of course, we deal with many projects, and some of the biggest ones are, of course, sports arenas and stadiums. So that's the topic of the presentation today, and I want to share the issues we find, the challenges we find, how we overcome these challenges, and so this is what this presentation is about. And we have to go step by step. We're going to look at, first, as always, why do we need sound in sports arenas? Okay, then we'll look at what are the elements we need to start a project, how we manage them, and how we accompany them all the way to the end. So, why do we need sound in sports arena? There is one fundamental reason for needing sound in the sports arena, and this is the audience safety. So we must be capable, of course, to manage the crowd. If there is an evacuation, if there is an incident, that's the minimum. That's the most important requirement, and that's the minimum that we have to supply. And this includes pitch. We will talk about it later, because if we have concerts on the pitch, then we also need to be capable to address the pitch. We just had the Olympics in Paris, and a couple of days from now we'll have the closing ceremony of the Paralympics. So yes, we need a sound system for all the specific events, not only the games, but for all the specific events which are in the stadium configuration. Depending on the sports, and we will look at that afterwards, the requirements of sports, we must know they're very different. The way we need sound for basketball is not the same than for football, is not the same than for baseball. So there are some specifics to each sport that we're actually dealing with. In the case of basketball, for example, as you know, there is a very long intermission time in between the moment the players are playing, and so there are DJs, there's a whole show that we have to take care of. When it goes to football or World Cup or Euro, of course, there are anthems, and the singers and the players are singers, and not the singers are playing. But anyway, so of course we have to reinforce these. Announcement, information about the game which is going on, goals, players change, etc. And the latest requirement, which is currently being tested in Europe and in France, is a very challenging one. In order to, as you know, there are many arguments from the audience to the referee decisions, and so the European authorities want to have a better communication from the referee to the audience, which means that the microphone that the referee has this is being tested, is going to be reinforced and has to be intelligible for the entire audience. Otherwise, it will add to the confusion. So you see, but again, this is being tested. It's technically very, very challenging. Again, a hand mic, is easy. A lavalier with intelligibility in all the stands, that's a bit of a challenge. And anyway, as you probably know, when you look at the revenue model of sports arenas, the naming is a significant part of that. So of course the sponsors, the commercials, everything which generates income from the promotion side, of course, needs also to be properly diffused with a good sound quality. This is, we don't see yet, you probably, you more than know that immersive audio is a big topic. And interestingly, all the immersive systems so far have been designed for an audience which is inside the speakers. And in the case of sports arenas, in reality, the audience is outside the envelope of the speakers. But there is no question, so far, technically it's a bit challenging to design an immersive system for sports arenas, but it is definitely to be anticipated that solutions will be found and that people will expect to have something which projects them sound-wise into the game. The same way we have the video screens now, which give different point of views and so on. So the same is to be expected with audio, of course. The different rules, I mentioned about that earlier. And again, the levels we deal with are different. The level of a rugby game is not the same than the level of a baseball game. The requirements are different. When we go to US, NFL, the level they require is significantly higher than what is required by the football here in Europe. So we have to be aware of all these things. And then last is, do we need or do we substitute to our main FOH? And I see here technical reasons for where the answer is no. And this picture is very good illustration. In reality, we cannot use the house PA system and we cannot time align it with the front of house system here, except on the very rear stands at the back, where the direction of sound is the same than the main front of house. But the side speakers cannot be time aligned, very simply, so they cannot be used. And that's the technical reason. And then there is the practical reason, I would say, or the responsibility reason, is that rarely a tour will connect to the house system because they don't know how the sound system works and they don't want to take responsibility for something they don't control. So that's also a responsibility issue. And all in one, what we want to do is we want to engage the audience into an experience. We want them to go there and say why. They won't eventually tell why they had a unique experience, but they had something, and sound is part of that. That's very, very important. To make it simple, an aggressive sound, unpleasant sound is not going to make a good experience, okay? And then suddenly, if I had fun, and I cannot explain why, there was the game, there was the image, there was the sound, there were all these elements, some level of interaction also, and so on, that will make it, wow, it was a great evening. Okay, so once we're being submitted a project, then the question is, what do we need to start? And we need many elements, not a PDF file. We need an accurate geometrical model, okay? Very often, acoustic models are too simplified as opposed to what we really need. Why do we need an accurate model? I'm not saying we need a 1 gigabit file, but we need to see all the shadowed areas. Quite often, the VIP lounges, which are an important part of the revenue of stadiums, are in shadow areas because they're below balconies. And there is no reason why these people that spend so much money would have a degraded sound as opposed to the stands. We need to have practical things like rack room locations to compute the speaker cable length and see if it's doable or not. The network, we need to have the available cluster locations, the rigging capacity of all the points, all these practical information. We need to have, if we want to commit to deliver end result, we need information about the room, about the venue. We need to know what the surfaces are like. We need to have eventually reverberation time, RT60 hypothesis. In reality, we need to have the materials when we do ray tracing. Again, I don't want to be too technical here, but ray tracing simulation is the most accurate currently when we want to evaluate. And if we don't go ray tracing, then we go statistical approach, acoustics, and then in that case, we need RT60 hypothesis. And if we don't have them, okay, if the venue is not capable to provide these, which happens, then we will go and we will measure. Because again, we cannot commit on an end result without having this information. We also need background noise hypothesis. I took a very extreme case here. That's the French president celebrating the 2018 victory in Russia. But the loudest I ever heard in a stadium was the monster trucks here at the Stade de France. And that was really loud. And so we have to put the announcement, the announcements have to be above that level. At the end of the day, you have a headache, which is absolutely terrible because it's really, really hard. But anyway, the background noise conditions how powerful the sound system should be. Right? We're not going to design for 90 dBA in a stadium because if we design for 90 or 95 dBA, it will not do the job in terms of what we have to go over the background noise. Okay? We also need environmental regulation. Quite often, sports arenas or stadiums are part of a urbanistic project, which means that eventually when they're built, they're kind of in the no man's land area. But the project is to have, a town being constructed around or having, to give some dynamics to the environment where the arena is built. So we have to anticipate that. You see, that's the Maracana in Rio. But if I refer to the Stade de France example again, it was really a no man's land when the Stade de France was built in '98. Today, it's a whole town, which is just next to the stadium. So we have to be very cautious on controlling the sound and monitoring the environment, of course. And then we eventually need to have the local regulation code of practices. Okay, here in UK we have the BS 7827. We have in US an FPA 72. In Europe we have the EN 54. We have to look at the text. Is the venue has to be compliant to this text? Yes, no. Take the best out of them. Eventually, if these texts are contradicting with what we want to do in terms of safety and quality, then we have to argue and we have to say why we will make an exception. Okay, but definitely we have to look at all the relevant regulations. Very important, and this is quite often forgotten. Most of the stadiums are open, okay, and so we have to look at the wind velocities. Again, back to this example of Stade de France in '99, end of '99, the 25th, I think it was on Christmas Day or the day after. There were wind velocities of 250 kilometers per hour. That's 160 miles an hour below the roof because we had a tempest. It happens once every 30 years, but it happens, and it tends to happen quite often. So we have to look at what are the wind velocities, what are the weather conditions for the mechanical design. That's extremely important. We cannot put the standard hardware that we use, okay, is certified up to a certain velocity. So if we don't exceed that, that's fine. And typically, depending on the location, that can do the job. But if we have higher wind velocities to take into account, we have to deal with that. And each authority locally has different values. Okay, the values here in London are not the same than the values in the Cornwalls or the values in Swansea and so on. So it's easy, in fact, because all the structurals, the roofs, have been designed for such hypotheses. So the speaker system must comply to that. Extremely important. Okay, and then of course the minimum we need, the minimum requirement is intelligibility. Sound system must be designed first for intelligibility. And what is intelligibility? I'm not going to give a class here, the time is too short about intelligibility, but you should just know that what makes a sound intelligible are the transients, okay? Therefore the consonants. If we talk to each other and if we understand each other, it's because the P, the T, the Q, you see, and all these are transients. So it's the ability of reproducing properly these transients that give intelligibility to the audience, okay? So one of the first criteria that was invented was the articulation loss in consonants. What is being used today, essentially today, is STI and its variants. So that's the minimum. And interestingly, music is also about transients. If we don't achieve intelligibility with the sound system, we cannot deliver good entertainment, good music, we cannot reproduce, which is why really intelligibility, in my opinion, is really the minimum. We should be way above that in reality. We must have hypotheses for frequency response. If the system is speech only, then it can be band limited. But if we want to entertain people in a nice way, we're not going to play music in a system which has such a limited bandwidth. It's not going to sound good, to make it simple. And in most of the cases today, we install subwoofers together with our sound system. And believe it or not, it's the last octave at the end, but it makes an incredible difference in the subjective perception of quality of a sound system. There's this bottom end, and people enjoy it, to make it simple. Okay. We need to have, I mentioned already, not only we need to have the maximum sound pressure level that we want to achieve, but we also have to agree together with the people who prescribe the sound system on how we're going to measure these. We don't want to argue at the end and say, no, it's this sound level meter, or it's this one, oh no, it's pink noise, or no, it's filtered. Depending on the measurement conditions, we can have 10 dB difference at the output, at the end. So we really have to anticipate that in advance, what are the conditions under which we want to deliver such SPL. This is just, sorry to say, anticipating and being professional and anticipating what we want to do. And of course, we need to have some specifications also about the frequency response consistency and the coverage consistency. We typically, when we design at NEXO, we look at a maximum of ±3 deviation on the level, and we look at a 1.5 standard deviation overall. Okay, so we cannot accept to have people who are listening 3 times lower than others in a venue, to make it simple. Okay, there is something we hardly talk about when we do designs, and very often we're quite constrained in terms of practical aspects, but STI intelligibility doesn't say anything about the sound direction. And you all know that if a sound comes from the back, I will definitely not have the perception of sound that if it comes from the front. We have what is called the cone of attention, okay? And if sound comes outside this cone of attention, we tend to move our heads to look at the sound where it's coming from, okay? And STI, all these measurements, criteria are monodimensional. It's just one point, and they don't tell about that. So yes, ideally, we try to put the speakers as much as we can to the front, because in open air stadiums, quite often we have no option. The sound comes from the back, and this is not the best in terms, again, of perceived quality. Okay, we talked about a little bit about weather resistance. Of course, when we put up a system there, it's typically for 10, 15, 20 years, easily. The lifetime of the systems in sports arenas is very long, and this is really good. The sound system for the Stade de France, it's the second time we do it, was installed in 2010, and it's this system which has been used for the closing ceremony of the Olympics in 2024, 14 years later, and the system is in perfect condition. So we have to look at these aspects. IP is definitely not sufficient to characterize how a speaker is going to resist outdoor. IP will just tell how it will resist to dust, how it will resist to water, but it won't tell over how many years. Okay, so we have to look at corrosion, we have to look at many aspects about it. Okay, and of course we know that the sound engineer is not going to go around all the rack rooms, morning and evening before an event, so we need to really design some customized interface nicely, so that he has access not only to all the controls, but so that he also access to all the default information potentially from the sound system. Okay, so we have to talk about redundancy. So this is risk assessments. Risk assessment is, okay, I have a component which is failing. What happens? Is it critical? Yes, no. If one component failing takes the whole system down, it's definitely critical, so we have to design accordingly. Okay, this is common sense. It's really risk assessment, as far as I see it, is definitely common sense. And then we have to look at a system requirement for the power backup. There are different approaches depending on the countries. According to the EN54, the system should be entirely backed up by UPS for a given time, etc. But EN54 typically does not really nicely apply to a stadium which is 80,000 capacity, because this means that the UPS has to be 2 times bigger than the actual amplifier racks. But anyway, if it's mandatory, then of course we do it. In other locations, there is a generator to back up, and so we need UPS just to make the transition, right, from the power to the generator, so that there is no interruption for none of the electronics. That's important. We know that there's a booting time for all the digital electronics, and we want to avoid that. We must avoid that. Okay, and then there are many elements which are outside the specifications that we have to anticipate. Talking in a sound system in a stadium which is 80,000 is not talking in a radio control room. So the way the speaker elocution is something absolutely essential. If he talks without taking care of the environment, it's going to be very unpleasant. So he has to interact, right, with the acoustics, with the audience, and he has to, his flow, his elocution has to be placed accordingly. So there are trainings, I believe ISCVE, if I'm correct, does training for this kind of situation, because it's really very, very special to talk. And so that's very important. We can have the best with the same sound system, and we can have the worst, just depending on how the speaker is going, to interact. Audio engineering skills. This is something that I find quite often. Sometimes sound in stadium is not very good, and it's not because of the sound system. It's simply because the engineer who is here, many times a freelance, is mixing in a control room with closed windows and has absolutely no idea at all, level, quality of what he's doing at the console. So it's a fantastic console, high-end, but the guy has absolutely no clue of what's going on. And if he's a freelance, he's totally blind, because it could be his first time in the venue. So training, it's not necessarily about having permanent employees as audio engineers, but it's again about training, and it's about giving them really a good anticipation of the relationship between what happens in the control room and what happens outside. Okay, if you ask me, I think it's probably one of the lowest costs in the budget of a sound system, and it's one with the most crucial impacts. This is definitely, I think, when we have festivals outdoors, when we have concerts, tours, the guys are mixing in location where they actually hear something which is similar to the audience. Okay, so that's a very, very important point. Then there is, of course, aesthetic integration. As we, over the last 10 years, 20 years, you probably realize that the architecture of stadium is becoming absolutely incredible. We could see that during the last Qatar World Cup. We see now that in Madrid, in the Santiago Bernabeu, there are pieces of art in terms of architecture. We cannot go in and put heavy clusters there and put something that really ruins the architect work. So we have to look at aesthetic integration. We have to visualize. We have to do all that. And of course, a good installation is not an installation that works on the opening day. A good installation is an installation that works over time. As I mentioned, for example, 14, 15 years, 20 years is not a short time for a stadium installation. So the maintenance aspect, the periodicity of what should be done every year, preventive maintenance, what should be done every 3 years and so on, this is the crucial condition for keeping the system in good condition for many, many years. It's quite an investment, money-wise. The maintenance contract is not a big expense, but it guarantees that this big investment that was done at first will be, sustainable. And then I'm going to talk very on a concrete base. One of the latest stadiums that we installed and opened, and thank you, Richard Vaughan, for being here, PAI Group, and because they actually did that installation. Principality was open, it was called the Millennium Stadium. It was open for the Rugby World Cup. Correct me, Richard, if I say something wrong. Back in 2000. And they decided to basically raise the level of their sound system. So we were solicited to do the design for that stadium. And I said it starts with geometry. So we start with our in-house software, which is called NS1. And this will allow us to do some direct sound evaluation. Okay, so we start balancing the sound the best we can. So we do this kind of designs. You can see we evaluate the frequencies which are critical. When we want to evaluate coverage, we typically look at, we can look at dBA, but even better is to look at where the ear is the most sensitive, because our subjective perception of a coverage is between 2K and 8K basically, and the ear is most sensitive at 3.7K. So this is how people are going to say, hey, I'm inside sound or I'm outside sound. So you can see we work within very, very tight tolerances. And then we move to an acoustic simulation software, which can be CAT and CAT acoustics, or quite often today is EASE. So this is EASE 4, now we work with EASE 5. And EASE is going to help us with the reverberation hypothesis to evaluate intelligibility and so on. So in the precise case of Principality, we did not, Principality can have open roof or closed roof. And so we had to evaluate that, and we did not have the RT60 hypothesis. So we went there and we did the measurements of the reverberation time in both cases, because again, at the time we commit, we commit for the end result. Okay, and so we cannot commit if we don't have these values. So we went there, we measured, and we built the models accordingly. And you could see we could evaluate all the surface absorption. And we always take the worst case example, empty. Okay? We design for intelligibility in empty stadiums. Reason why is that in a stadium, you can have a show with, you can have an event, a private event or whatever, with 5,000, 10,000 people, and the entire PA on. And these 10,000 people are not going to change the acoustics of the stadium, yes, but you still have to evacuate them. So taking the worst case scenario and making it better afterwards, that's fine. The opposite is just not allowed, okay? So we have cases, and this has occurred here in UK 1 or 2 times, where we said, no, we're sorry, we cannot make it. You know, the acoustic of that stadium is too live, we cannot do it, and there is no sound system that can do it, okay? So it requires acoustic treatment. But again, you know, we take, I believe, important responsibility at the time we implement a sound system in a stadium, and so we cannot commit to things we cannot deliver. That's really very, very important. And you can see here when we built the model, and when we created the model, the quadrants are always a bit of a challenge in stadiums. It's very easy to, quite often the stadiums have the same cut view, so it's easy. You design one cluster and then you just duplicate them. Yeah. But you see, in that case here, the quadrants, they're kind of, yeah, they're difficult. They need a very wide coverage on the upper stands, they need a lower coverage on the lower stands, and so on. So anyway, so following that modeling, there were a couple of modifications that were implemented. You could see the direct sound or the total level did not reflect that, did not show that. It's only once you run the STI that you can actually see what is going. This is done on ray tracing, and this is a computer which is running overnight, basically a dedicated computer which is running overnight for 8 hours or 12 hours to get there. Okay, so full prediction. Ah, sorry, I'm going the wrong way or what? No. Then we generate an equipment list because we work hand in hand on one side with consultants and on the other side with the system integrator. And so we provide exactly, you know, all the items that are needed, amplification-wise. Depending on the rack room location, again, we're going to design the racks and see what is needed. So you can see here the block diagrams. In the case of Principality, we have 4 rack rooms for the main PA system. We provide all the elements. When you build rack rooms, of course, you need to know about the power consumption, you need to know about the thermal dissipation that is needed, etc. All these practical aspects. You see, we're going outside acoustics now, but these are really fundamental also, because this is also part of what is a relevant project, a successful project. So again, block diagrams. Am I going the, yeah, sorry, I'm going the wrong way. The cabling, the mechanics, okay. Can the standard hardware of NEXO do the job? Yes, no. Again, all relating to wind velocities that we have to look very closely. I think that in the case of Principality, we were asked to take into account winds of 110 kilometers per hour, if I remember well, Richard. And this was above the 72 kilometers per hour that our system are always certified for. But we evaluated and we found that the clusters that we had, which were 8 cabinets, if I'm correct, per cluster, yeah, with the current NEXO accessories could handle 120, up to 150 kilometers per hour, no problem. So again, a case-to-case situation. Then we built the home, you know, the custom design interface in NEMO, which is again our solution. But this can be done in QCs, this can be done in provisionaire. Usually, of course, in stadium, you find interfaces which are going to manage everything. So very likely it's going to be a QC is very popular, or a provisionaire design from Yamaha, for example, just as examples. And you can see here, then again, key. Of course, we're very happy to win a project. That's very clear. But at the time a project is won, we have to follow up. There is not a single project, and this is absolutely normal, there is not a single project where modifications do not occur at the time construction or refurbishing is going on, okay? There is this, I don't know, heat pipe which is going there, there is this camera which is going there, and so on. And so we have to modify the design. We have the height of the cluster will be lowered, the angles are going to change, and we have to do that. It's not exceptional to have, it's the day-to-day life that projects actually are modified during this installation time. So following up is absolutely essential. You all know that a 2 or 3 degree mistake on a cluster in a stadium is 1,000 or 2,000 people that are not having the proper STI. So you see, we're really working inside very, very sharp constraints, and following up is the only way to go. Okay? And then at the end, because together with the integrators, we committed to a result, well, we have to self-verify what we've done. So of course we're going to go and we're going to evaluate, we're going to do all the measurements, and we're going to look at what we got, refer to what we committed to. So you see, this is the engineering support team here with the venue manager at Principality, and this is the mapping of all the points. And when we return to Principality, we take all the same points and we remeasure to verify that it's all okay. And then one of the very first games that was nice was the France versus Wales, and that was, when was it? May, June, I forgot. It says there? Yeah, March 10. That was one of the very first, so it's great. And rugby, I mean, France won and we were very happy, but rugby is always, a very nice celebration between teams. There's a great spirit in rugby. So that was really a special event and fantastic, of course. And so I finished this presentation with big thanks to PAI, because they're really the one who did this installation. Should I mention, doing a sound installation in a stadium is not the same than doing a restaurant or doing a bar or a hotel. There are logistic constraints which are extremely heavy. The distances are extremely long. Whoever worked in a stadium know that it's not unusual to walk 10 miles in a day. And if you don't walk 10 miles in a day, you've not been in the stadium in reality, okay? Because this is how it works. And anyway, so yes, there's a set of skills on the integrator side which is absolutely essential. It is difficult working environments. It is difficult conditions. Safety, of course, because we're quite often working in height and so on. So definitely, the good partner for a stadium is absolutely crucial for a project. And I'm going to conclude, and that will give us a little bit of time for question and answers, if there are any, with some of the references we've been working on. So you see, we work in arenas. This is a multi-purpose arena south of France, in Aix-en-Provence. This is the Swansea Stadium, which was done. This is the Swansea Stadium, which we did 2 or 3 years ago, if I'm correct. Yes, with a Plus Series. Capacity is around 20,000. This is the Stade de France, which we did back in '97 for the World Cup, and that we did again in 2010 because they had to. The installation was amortized 15 years later, and they had to redo it. So this is the place that hosted many of the athletic competition. So you can see a picture here, and you can see we have 300 GOS12 installed here, plus 8 clusters for the pitch. So we deliver 96 dBA on the pitch, and this already was used because we had some dramatic events at the Stade de France where we had to evacuate people on the pitch. So very, very important. Optus Stadium in Australia is being said as the best sounding stadium in Australia. And you can see here, when I talk about, you see the stadium is open at the back and on the top, so the wind velocities can be extremely high. And you see it's a special hardware that was designed in that specific case. The structural report for the clusters is 250 pages, okay? And so it includes subwoofers and so on. And we have hundreds of ID24s, which are small cabinets that sound beautiful at NEXO that we have, because you can see below the balconies, everywhere we have VIP lounges. Principality, I discussed about, going in the wrong, going in the right direction. Okay, so nice picture here. Toyota Stadium in Japan, which hosted the previous Rugby World Cup opening and closing ceremony, and that was in 2019. Okay, so again, beautiful. You can see opening roof again, so we have to evaluate all conditions. So you see all these topics I've been talking today are really topics that are very recurrent, do you say? Very recurrent? These are questions that you should systematically ask yourself, when you go, because at some moment in the project, you're going to deal with them, you're going to face them, and nobody should, forget about them. And last, that we're very proud of, and this is ongoing because this is on construction, is the Everton Stadium in Liverpool. Thank you very much. Yeah, I'm done. I tried to, it's lots of information. I tried to leave a little bit of time for question and answers, and we have a little bit of time, so I put my headset.
Can you hear me? There we go. I'm not very familiar with the NEXO products, but are the speakers that you're using in the stadium specifically designed for stadium use, or are they multi-purpose cabinets that you could use at festivals or other installations like clubs? And
we have a weapon at NEXO, and that weapon is the GOS 12. And the GOS 12 is powerful, is very cost effective, and it has this unique feature that you can do in fact there is a 10-degree version and a 30-degree version. And when we built a cluster, we can go all angles, we can go all angles from 0 to 30 degrees. Okay? And this is what makes it extremely successful in sports arenas, because if the roof is here and the stands are going all this way, you're going to need a very wide angle for the people who are close, and then you're going to go to very narrow angles as you want to go to the bottom stands. Yeah? And so not only that, but the horizontal coverage is also configurable, because when you're shooting far, of course the coverage is wider, and when you're shooting close, then it's very narrow. So if you want to work on fixed location for clusters and not multiply the points, then we have this ability. And so budget, the cabinet is 16 ohm, so we can put 16 of them on one amplifier unit. So, the performance versus budget is really unique. That product is in NEXO catalog for quite some years now. It was used in touring some time ago, but we launched a new series which is specifically designed for touring. So S12 is our weapons for stadium. It's EN 5424 certified. We have all the certificates, the rigging, etc. So so I strongly encourage you to look closer at the NEXO catalog and see what it does. Yeah.